I'm going to show you guys how to do one of these problems both ways, and after that, I never want you to do it the other way again. Just know it exists, just in case, right? There's one way that's easier than the other. So today, again, substitution with definite integration. We've only done indefinite integration with U substitution up to this point. Now we just use those techniques to perform this integration, but there's this one more thing we got to learn today, and it has to do with the boundaries, I think. Actually, I don't think. I know. Okay, evaluate each of the following. There are two ways. Again, on these ones, I'm only going to show you it once. All right, if we look at this problem, we're like, ooh, that's a composite function with a multiplier. We do not have an anti-product rule, so I'm guessing U substitution, right? When in doubt, U sub, okay? All right, so again, I think you guys already know this one. U equals x squared plus 1, and then du, and that would be, what, 2x dx. And then we take a peek up at the integrand again, and we're like, oh, okay, we only need an x dx, so I'm getting rid of this 2, so I'm going to be 1/2 du equals x dx. We'll throw my x up there, dx. We go with that so far? All right, now let's do this. Let's write our antiderivative. Do not put the boundaries in place, please. Okay, so that'd be what, u to the third, right? 1/2 out in front, and then du. Scalar multiplier, we know we can just move out in front. Why do you guys think I'm not putting the boundaries on this antiderivative right now? And that is a big part of it. What variable are these bounds in terms of? X. This is in terms of u. So that means we can't use the same 0 and 1. We got to leave them out now. Okay? And that's okay to do that. And then put them back in when we have, or use them when we have that antiderivative back in terms of x. All right, let's find the antiderivative. Okay, base to the fourth, multiplied by the reciprocal. Right? And then that'd be what, 1/8. And then parentheses x squared plus 1 to the fourth evaluated from 0 to 1, right? And I know we can use our calculator to figure these out right away. It takes like 30 seconds or less, right? But most of these problems like this are going to be in the non-calculator portion of the test. Okay, so try and do all these problems without a calculator. Use your calculator, check your work, okay, to verify that you are right. All right, so what we have, 1/8, and then we have 1 squared plus 1 to the fourth minus, I'm going to take the 1/8 with it just for fun. 0 squared plus 1 to the fourth, correct? We okay so far? Keep an eye on me. All right, 1 squared is 1 plus 1 is 2. What's 2 to the fourth? Minus 1/8. Okay, that'd be 0 plus 1. 1 to the fourth is 1. So times 1. So that'd be what, 2 minus 1/8? And that'd be 16/8 minus 1/8. So that'd be what, 15/8? Again, if this was area, this would be unit squareds. If this was a rate from like time equals 0 to 1, this would be the amount, right? Okay, questions on this so far? Well, pretty much like everything else in math, we'll show you the way we don't want you to do it. We'll show you the hard way first, and we'll show you the easy way, right? This is the way I want you to do it. Ready? Everything the same up to right here. So we'll call this way 1. We'll call this way 2. Put a smiley face next to way 2 because that's the way I want you guys to do it. Now we have this antiderivative, 1/2 u cubed du, right? And we already acknowledged the fact that the problem is that these are different variables now, right? Well, could I change the bounds so that they are in terms of the variable that we're using? If x is 0, what would u be?
1. Yeah, 1.
How would you calculate it? Yeah, we have an equation that relates u and x together, right? If x is 0, put 0 in, 0 plus 1, that's 1. If x is 0, u is 1. If x is 1, what's u? 2. Now, we can just find this antiderivative. So we'd have, what, 1/8, and that would be u to the 4th. And look at how many steps we're going to be able to skip now. Evaluated from 1 to 2. Is this a little bit easier to plug in? I think so, right? So we'd have 1/8, 2 to the 4th, minus 1/8, 1 to the 4th. And that would be 16 over 8 again, which would be that 2 minus 1/8. 16/8 minus 1 is 15/8. What? That's all right. Okay, I think this is a little bit easier, isn't it? So, once you convert to u on depth integration, there is no need to go back to your x. Yes, that's supposed to be dating advice. All right, let's look at this one then. Obviously, what's our u choice going to be? Let's see if it works. Okay, du. That'd be 2 dx. Take a peek. Nope. So 1/2 du equals dx. What? What else we need to do? So we have dx covered up. We have this as u. Uh-oh. So we learned yesterday, right? Change a variable. Okay, well, use this equation again. So that'd be what? U plus 1 equals 2x. And then yesterday we talked about just writing it as 1/2. U plus 1 equals x. Don't distribute that 1/2 through, because we can make it a constant multiplier out in front. Make our life easy. All right, so let's do this. Antiderivative. Okay, I'm going to write it kind of how it looks right now and then rewrite. So that'll be u. Okay, du is 1/2, or dx is 1/2 du, so 1/2 goes out in front, and then du goes right here. And then x is 1/2 u plus 1. Well, the other 1/2 can go out in front too. U plus 1. Huh? Yep, I just did this morning, first period. Yep. All right, and the big idea is we're not be able to substitute for something still in the integrand. Well, use this setup, this equation you determined, which was u, solve for the variable in question, and then just make a substitution. That's all it is, basically. Okay. All right, use your rewriting skills. That'll be u plus 1, u to the negative half power, du. And yeah, you could split this up. Some of you guys yesterday were splitting this up. U over u to the half, 1 over u to the half. That's fine. I don't know why I'm bringing it up as a multiplier. You know what I mean? And then antiderive. Okay, u to the 1 times u to the negative 1/2, that'd be u to the half, plus u to the negative half. And this problem looked like yesterday's problem, I believe, right? So next, except for today, it's definitely integration. All right, so 1. Oh, what did I do? I'm missing something on my integrals. The what? Yeah, the balance. Okay, let's do that. We could, because if we change it to u and we know we're going to leave in terms of u, just write your balance in right away. Write your balance in terms of u. So if x is 1, say again? U is 1 also? Okay. If u is 5, that'd be 9. I kind of like that. The reason why is because I know these are like square roots, right? So if we have square numbers, this problem's not too bad. All right, 1/4. Let's actually find the antiderivative now. Okay, u to the half. So base, add 1, multiply by reciprocal. And I'm going to put parentheses around that. Okay, plus base, add 1, multiply by reciprocal, 2. Evaluate from 1 to 9. All right, 1/4. I'll leave that as a multiplier. And we got 2/3 times 9 to the 3/2. 2 times 9 to the 1/2 minus 2/3, 1 to the 3/2 plus 2 times 1 to the half. Boom. Just enough space. That's why I put this parenthesis right here. I just choose not to distribute it all the way. I'll probably need another parenthesis there also then. Okay, 1/4. And if you want to, you can distribute that to right here also right away. It's up to you. Okay, remember how this goes. We got 2/3 times, okay, we're taking the square root of 9 and then cubing it. 27. The square root of 9, that's easy. Minus, that's just 1 times 2/3. And that would be what? 1 plus 2. All right, 1/4 still. 1/3 of 27. Was that 9? And 9 times 2 is 18. Plus 6. Minus 2/3. Minus 2. All right, what do we got here? Is that 24? Minus 2? 22 minus 2/3. Say again? Would that be 66 minus 2? That'd be 64/3. Is that right? 64/3 times 1/4. Well, that's kind of convenient. What's 1/4 of 64? 16, so 16/3. Anybody checked out with the calculator yet? You have faith? All right, that's good. Yeah, give it a shot. Let's get some people checking. Right here? Well, I did 3 times 22, so 66, then minus 2 of those. That's right. It's good to question stuff. That's all right. Confirmation? It's about 5 1/3, right? Sweet. Again, that choice for back substituting with X is up to you, but I think you guys clearly saw changing your balance so that in terms of U is the best way to go. The AP test, they rarely back substitute the X on the antiderivative. However, like I said yesterday, sometimes they don't necessarily want you to find the antiderivative. They want you to use some topic that relates to finding the antiderivative, right? So if they give us this antiderivative up here, they say, well, what's an equivalent expression maybe? Okay. And then you look at the expressions they give you and you see U's there. You're like, this is U substitution problem, right? So let's go as far as we can until we get one of these. All right. Now, before we begin the problem, what do you think they're checking to see what mistake we're going to make? It's the balance. It's using the balance or the wrong U, or forgetting the constant. So there's kind of the 3 things they're checking. One of them is the balance. The other one would be the constant, and then the wrong U. Okay, this kind of leads us off to the right U choice, I think, though. All right, U equals x cubed minus 2. Du then would be what, 3x squared dx. Okay, we got x squared, we got dx, means this 3's got to go out in front, so 1/3 du x squared dx. Okay, let's see here, antiderivative. I don't put my bounds in until I have everything written, then I figure out what my bounds are. If you want to do it that way, or if you'd prefer to change your bounds first, it's up to you. Okay, that's just the way I do it. 1/3. Okay, that'd be square root u, correct? Du. That's the du, 1/3. Now bounds. If x is 2, what is u? Well, 2 cubed is 8 minus 2 is that 6. 3 cubed, 27 minus 2 was that 25. Do we have one of those answers? God, and none of the above just makes us question our existence, doesn't it? It's just, come on, man. Just give us a choice. What is it? This one? So C? All right. Notice, do they have the same answer without the 1/3? Right here. Do they have the same answer, but the boundaries aren't changed? Right here. So they're going to have all possible wrong answers. They're the most popular wrong answers that people do by making those mistakes. They're checking to see if we know how to take care of this guy, how to take care of these guys. Okay, not necessarily just find the antiderivative of square root u. That's pretty easy. It's everything else they're checking also. Okay. All right.